All right, guys, in the last video, we proved that if a function was differentiable at some point, then that function must be continuous at that point. I'll direct you to the last video if you didn't watch that one. But I want to talk very quickly about the converse. The converse of if a function is differentiable, then it must be continuous, is if the function is continuous, then it must be differentiable. I'm just very quickly going to tell you that this is false, and I'm going to prove that falsity by counter example. And I would direct you to the function f of x equals absolute value of x at x equals 0. Notice, continuous function at x equals 0. Non-differentiable because it has a corner. So it's sometimes useful once you've proven something to take a quick look at the converse, because it's nice to know, can I go both ways? Well, now in this case, if I tell you it has a derivative, you can say must be continuous. If I tell you it's continuous, you cannot conclude whether or not it has a derivative. Guys, very quickly, one last thing, the intermediate value theorem for derivatives. I'm not going to spend much time on this. We're not going to be really using it in AP Calculus, but it is in the book. The intermediate value function for derivatives, or the intermediate value theorem for derivatives, says that if I have some differentiable interval, and there are 2 points, A and B, inside that interval, that the derivative of the function must take on every value in between those two derivatives. So I've got f prime of A, I've got f prime of B, and every possible value, f prime of C, must include every value between. Okay, now C is not a particular point on this graph. C is just that the derivative, and if you wanted, we could probably just go back and say f prime of x must include every point in between, or every value, rather, excuse me, not point, every value in between. In other words, we can't get from a slope of 0 to a slope of 1 without going through all the slopes in between. As you get steeper and steeper and steeper, you got to go slope 0.1, slope 0.2, slope 0.3, and so on. Again, I don't think that this is a crucial thing for AP Calculus, but be aware of it. You can't get from slope 0 to slope 1. You can't get from slope 1 to slope 5 without going through the stuff in between, so long as the function is differentiable. Obviously, this doesn't apply to absolute value of x, because here I got -1, here I got 1, and I didn't go through any of the slopes in between. So if the function is differentiable, then to get from one slope to another, you have to go through all the slopes in between. All right, cool. That's it. Not going to ask you any more questions about that. Be aware that it does exist. And why don't you go ahead and do exercise 37 in your books? Again, that's just for my classes, working out of the book that we're working on, which is mentioned in the description. Cool. That's it. Next video will be a 3.2 recap. See you then.